All right, hey, what's up guys? My name is the Cherno. Welcome back to another Cherno live stream. We are back this week, fresh set of work to do, same old project, but we're getting somewhere now. We're getting somewhere. I'm very happy because last time we ironed out some bugs. Last week was actually, last time we streamed was actually pretty good. We got some good stuff done. We basically kind of solved the problem-ish of the linear filtering not working, and like basically our samplers not getting to our shaders. And we also spent like a little bit of time going through like this stuff over here and making sure that our labels actually render for our assets inside the content browser panel, because that was not happening. Basically, this text over here was just like blank. There is still some issues with the rendering, like with the ImGui stuff, like for example, skeleton is cut off. That's not to do with the new renderer, I would think. I think that's more to do with the fact that we went forward 2.5 years with ImGui. We jumped forward to a much newer version. And because of that, there's like we had some custom stuff, some like extra stuff on top of it. There may have just been some changes to layouts and, you know, various calculations that may have been done as a result. So that's basically where we're at. Audio delay. I hope there's no audio delay. There shouldn't be, but I guess I'd have to listen to it myself. Other people can tell me if there's an audio delay. Right. So yeah, but we still have like, if you pay attention, you might notice that even though we have filtering now, so you can see there's like these gray pixels over here. That is as a result of linear filtering happening. So in the actual source image, it's just two colors. It's transparent, so like nothing, or it's like this white color. That's it. So all of this stuff is transparent. So because it's kind of like one bit, we know that if we see other pixels here, then obviously filtering's happening. Also, it looks much nicer, and this stuff up here, for example, looks nicer because you can see it's got all those gray intermediate pixels as well. So that's definitely working. However, it still looks worse than it does on existing Hazel. So if we have a look at like the net branch, for example, which is using the old renderer the old renderer, the old ImGui, before we kind of started this current renderer 2025 project, then you can see that like, what's a comparable thing that we were looking at? Like anim. Do we have an anim here? Yeah, you can see that the anim is much smoother. I mean, I don't know if you can tell without me zooming in. I can see it, but this is much rougher than this, and I would think that that would be as a result of MIPS, because we are definitely linear filtering it now, but it's probably not as smooth because it's probably picking a much like lower LOD, kind of like a lower MIP level, because this is much smaller than the source asset, which is 512 by 512. So if I was to render this at like 512, you know, it would look pretty good. I mean, there's still like a little bit of filtering going on, but oh, and that's not showing up, but that's okay. I don't really care. But yeah, these are kind of comparable now. They've still got like a little bit of that filtering, but if you have a look at this anim over here, and then oops, these two basically side by side, they look identical to me. So it's almost certainly a MIP issue, because we're not actually generating MIPs at all yet, and that's okay. We'll do that later. The reason why we're not doing that is because the way that we generate MIPs in Vulkan is using this function. There's basically like a blit function, so you can actually resize an image into a different size in Vulkan using like, you know, you'd write the commands into a command buffer and execute it. So it still has to like go through that stuff, but it's got like a built-in blit command, whereas DirectX 12 doesn't. And so the way to do this in DirectX 12 would essentially be to like use a compute shader or something like that to actually do the filtering slash downscaling, downsampling. So we need to write that. It's still very easy to do. It's not like we have to manually write the filtering algorithm, but we do have to go through that pipeline and actually execute it, whereas with Vulkan it's actually got stuff built in for that. In OpenGL it's like the easiest. It's just like literally GL like generate MIP maps and is done. But in Vulkan you still have to go through and actually refilter everything. I can actually show you what that looks like. If we go to like Vulkan texture, it doesn't matter that I spelt it wrong. Generate MIPS. So you can see that this is on the other branch. the existing branch. So you can see that what we actually do is we go through every MIP starting from MIP 1, because 0 is obviously the original image. And then we go through and we kind of create this like blit command. We have to use like image memory barriers and everything, but this is it, VK command blit image. And then we basically say that we're going from a source, which is basically a higher resolution width and height, than this one, which is going to be, you know, divided by 2. Basically, it's going to be, we're doing like shifted right by the amount of bits, which is effectively like dividing it by 2 every time, because that's how MIPs generally work. So, and then we go through that in a for loop until we have all the MIP levels down to like 1, 1. So that now has to be replaced because the like VK command blit image, there is no equivalent in DirectX 12, and NVRHI obviously supports both, so therefore it doesn't have this. And then you have to basically write like your own computer shader. So that is how that's how it works. There's a minor audio delay compared to Cherno's pretty webcam. Really? I wonder why. Because I've never really had that before, I don't think. I can try like, I wonder if it's the camera. If I deactivate and reactivate that, don't know if that will help. But maybe I'll try listen to it then, since people are saying it's real. How should I do that without being intrusive? Probably on my phone. That would be that way it's not going to play back for you guys. Okay, let's see. Watching my own live stream. Okay, you guys are going to hear it a bit. I think it's okay. Let's do 3, 2, 1, action. I'll just wait for that. I think it's okay. Let's do 3, 2, 1, action. That's pretty good. That's fine. I'm not really noticing a delay, to be honest. Maybe after I deactivated and reactivated the device, it went away. I don't know what it was like before then. Anyway, so yeah. Anyway, that's the MIP map situation. I'm just telling you why that doesn't exist at the moment. And also, I would rather not like spend time doing that. That, in my eyes, that's like a refinement thing, because you don't really need MIPs. You just use MIPs because they make things look nicer and possibly help with performance as well, usually. So that being said, since we have all that working, apart from, again, just edge cases and various minor things, like for example, the cog over here for the settings for the content browser panel, which brings up this thing, and you can like toggle like the asset types as well as the thumbnail size. That doesn't exist. So it looks like this normally. Oops, let me make that. So it looks like this normally. It's just like a cog. So that's probably just like not aligned correctly, and it's being like clipped or something. It's not rendering on the screen. So stuff like that, it still exists, and we need to like more or less fix that. But otherwise, everything, you know, generally works, and we obviously have like viewports as well, so we can drag this out and, you know, do whatever we want with these windows. They all create their own swap chains dynamically and their own windows and everything. And it's a very seamless experience, which is awesome. So there's like part of rendering part of the main window, and then obviously as soon as we drag it out, like you can't, there's no flicker, there's no, there was a flicker before I updated my GPU drivers, but yeah, there's no flicker now. There's no delay or like, everything's great. It works beautifully. So that is awesome. And I have in fact committed this. I'm behaving a bit unusually because I've been committing like every live stream. And so that's what we did on the 12th of June. So that stuff is all, you know, working now. And, yeah, and then we also had the weird thing where half the stuff wasn't rendering because we weren't properly using like NVRHI's state, like texture state and all of their like state management tools. We weren't really, or their state management system, we weren't really like using that properly. So we fixed that last live stream, as well as the memory leak. So now you can see our memory is very consistent, whereas it used to, you know, get up like 10 gig every 10 to 20 seconds or something. And the reason for that was because we were not running NVRHI's garbage collection, which specifically seems to affect command buffers. And because we were creating command buffers, well, we weren't creating command buffers, but we were executing command buffers every frame. It kept retrieving like new ones from a pool and creating a new pool for the new ones every time. And we did that because we were running at like probably over 1,000 frames per second. It was accumulating really quickly. And so the fix for that, because I know some people were interested in that, was basically inside our main loop, inside the application.cpp file, we do this now. So we get the graphics device, which gives us the NVRHI device handle, and then we run a garbage collection on that every frame, as the documentation tells you to do. The desync is getting worse and worse over time, it seems. What is going on with my live stream setup today? Let me test it again. 3, 2, 1, action. People watching on YouTube are gonna be like, what's going on? No, I gotta do that again. 3, 2, 1, action. Probably don't need to say 3, 2, 1 every time. No, I gotta do that again. 3, 2, 1, action. It's fine. What are you guys talking about? There's literally no delay. All right, whatever. So this was the garbage collector. Maybe I'm just being trolled by you guys today. This was the very, very important thing. If you're using NVRHI, don't forget to run this once per frame, at least once per frame, according to the documentation. But again, it seems to, like, basically if we go to like the Vulkan, at least on Vulkan, the Vulkan backend, the only thing that it does is it basically goes through and retires command buffers, which basically adds them back into this like, command buffers in flight or whatever. So that the idea is that actually it adds it to this command buffers pool, because the idea is that every time we do a get or create command buffer, you can see that if there's something in the pool, then it will actually get it from the pool. Otherwise, if it's empty, then it creates a new command buffer, and that's what was happening, like probably over 1,000 times per frame. Sorry, per second. 1,000 times per frame would be a lot. 1,000 times per second or so. Okay, so anyway, now that we have established and we've caught up and we know what we're doing, this is very exciting because the next step really is to actually start working on Hazel's renderer. So this was also kind of Hazel's renderer, but this was obviously the UI renderer. And that was ImGui and all that stuff. So even though it's going through Hazel's code and we're the ones rendering it, it's still not exactly, it's not Hazel's like 3D rendering, and none of this makes it to the runtime and to any shipped games. I think that you can technically enable ImGui for the runtime just because it might be useful to use some debug UI for your debugging. But yeah, generally speaking, obviously none of this actually constitutes the game, which is inside this blank viewport. So we can move on now to, yes, NVRHI absolutely works on AMD GPUs. It is nothing more than just an RHI. It uses DirectX and Vulkan. So it works the same as Hazel's RHI did in the past. Okay, so, yeah, it's basically irrelevant that NVIDIA are the ones who made it. They just decided to make it because they happen to have a thing or two to do with graphics. But in terms of the manufacturer of not the manufacturer, but the author of the library, it's irrelevant because it doesn't have any like NVIDIA specific code apart from for like extensions like you would see in any RHI. All right, anyway. Oh yeah, and then you can see this is a bit misaligned as well. But again, I don't really care about this at all, and MIPS would probably really benefit from these icons because they look like crap. But let's focus now on the viewport, because this is like this is really the major thing. Like what we've been doing so far has been somewhat minor. I don't want to call it minor because even though the actual rendering that you're seeing for ImGui is definitely, compared to the 3D renderer, it is definitely minor. It's still like, the work we've done thus far has still been really quite a lot, because obviously getting NVRHI actually working, but also changing Hazel's entire like window system, swap chain, device manager to all use NVRHI, that's a huge change. So we've done a lot of work to get to this point of actually running Hazel, like using NVRHI. Yeah, so I'm feeling pretty good about the rest of this because, and also like we're still doing a lot of stuff. We are still kind of cheating in a way and going through Vulkan-specific code, whereas we need to try and distance ourselves from that. But like, you know, the renderer class, for example, is still going through and actually compiling all of our shaders, for example, right? So that doesn't need to change. It's not like we have to rewrite all our shaders. So we can see we've got a lot of shaders. These are all shaders that we're compiling, and they work, and they're basically available right here. Yeah, which is awesome. And you can see that we're able to use them within NVRHI, because if we go to our ImGui renderer, sorry, is it ImGui renderer or ImGui layer? ImGui renderer probably. Yeah, you can see that we do renderer get shader library ImGui. So that basically refers to this ImGui.HLSL shader that we compiled as part of Hazel's renderer and Hazel's shader compiler and Hazel's shader system. And then all we have to do is to get NVRHI, which it wants basically handles when we end up making this pipeline, graphics pipeline object. It wants handles for whatever shaders we happen to use, right? So the pixel shader and the vertex shader in this case, and we can just retrieve them, you can see, from that actual Hazel shader using this API that I've made. So that's pretty cool, because you can see that obviously we can create everything now. Now this vertex attribute layout and stuff, we've also already ported a lot of Hazel's existing classes to NVRHI. I actually did that before I started focusing on ImGui and before I really started streaming all of this. So for example, you know, we used to have specifically a Vulkan pipeline, which is actually gone now, I guess. It's probably deleted it. But we basically used to have a Vulkan pipeline that went through everything, you know, in Vulkan, and created like a Vulkan graphics pipeline. But now the pipeline class, we've removed Vulkan pipeline. We just have pipeline. We don't have like a different subclass per render API anymore. And when we go through this, we actually, you know, create like a pipeline using NVRHI. So we've already got that code, which is pretty cool. Now what I wanted to check actually is to make sure we have like the vertex attribute descriptions, but we should, right? Yeah, here they are. It's just we're just doing them a little bit differently. But yeah, we should have basically the same. Well, like I ported all of this stuff like a while ago, you know? So that means that I'm sure there are bugs and there's things I've missed, and there's a lot, you know? It's a game engine, like it's a 3D game engine. There's a lot to do with rendering, and there's like lots of, it creates like a lot of different variants of things, and the configurations can be like, the specifications of different objects, you know, in the renderer vary wildly. So there might be things that I've missed, but you know, this works, like as in this is present. So now I got to think about like how I want to actually start implementing this stuff. Meaning like, how do I want, like, where do I begin? Because at the moment the viewport is just blank. And if we have a look at why the viewport is blank, it's because I've disabled it. But if we have a look at why, I think it's because mostly in the onUpdate function inside editor layer, which is like the main application layer for this editor program, this editor application, the first thing I do is return, right? So I've just like exited out of the function. I'm not really calling this function anymore. This is what it's supposed to do, right? And so it goes through, and you know, if the scene state is edit, which means we're not in play mode, we're not playing our game, then it will go through and do edit a scene on update editor and on render editor, and that will basically, it takes in a viewport renderer, which is a scene renderer. And it will go through and basically, you know, it'll go through all the necessary components that we have inside the entity component system, inside that scene, so that it can actually do like renderer begin scene, and then submit all of like the static meshes and the, you know, non-static meshes, the dynamic meshes, so like animated meshes and meshes with their own hierarchies and everything. And then render end scene. So it will go through and actually, you know, render everything. And then finally, if we have an image to render to, we'll do the 2D rendering on top of that. So that's like for things like text that is rendered by renderer 2D, but it's in 3D space. I mean, it can be in screen space, but yeah. And I think we also do like sprite rendering and stuff at that point in time. So there's quite a lot, right? And that's it. So we're not doing any of that at the moment, but also what's happening is, I think since we're showing gray, I believe inside the viewport panel, which is here, So we basically, if there is a final pass image here from the viewport renderer, which is a scene renderer instance, right? If we have one, then we actually render this. So this is rendering it using ImGui, right? It's just basically taking in the image and it's rendering that image in that viewport panel. So how is a scene renderer structured? That's a topic for another video probably, or another stream. I have on Patreon, I have some exclusive videos that go through like the renderer specifically. I think I have like a multi-part series. It is the old renderer, but it is basically the scene renderer is not render backend specific. It's a very high level kind of class that basically takes in like a scene as an input and gives you an image as an output. So it doesn't, it obviously calls the low level renderer, but it itself is not the low level renderer. So that is not really changing as part of this like refactor or like, yeah, rewrite, I guess. It's more of a rewrite than a refactor. So I guess what we should do is let's have a look at if we're even initializing the scene renderer, because I imagine we would start with the scene renderer. Like we would start getting the scene renderer to actually, render something, right? So if we have a look at viewport renderer, yeah, so I've commented out us creating it, and I've replaced it with us creating it with no parameters. So we made it so that we could still initialize scene renderer, but I think I actually added this default constructor, which doesn't take in a scene. So that's, we can basically get rid of this and we're gonna bring back this. So we're not gonna worry with the second viewport renderer, I think, because we do have a second additional viewport in Hazel, but to be honest, I haven't looked at that in a while, probably doesn't work. And I don't know if that's something that we need to have. I guess that would be not bad to keep, so we'll see. But anyway, now we're actually creating a scene renderer with a specific scene. So this is important because we'll get rid of this. It's important because, or like it's a substantial amount of extra work that happens because when why does it keep jumping to there? Because when we create it with, if I just go to the constructor, when we create it with parameters, it actually calls init, whereas it doesn't if we don't. And you can see that this is now gonna go through and actually set everything up. So like these uniform buffer sets, these, the renderer 2D even, the shaders, the, all the pipelines, these like vertex buffer layouts, these like, all the actual pipelines are now, the compute pipelines, the graphics pipelines is actually gonna create all of them. So this is where we're gonna probably spend the next few weeks, I imagine, because this is obviously this is the biggest part of everything. This is it. This is the meat. This is the juicy part that we're up to now. So, where to begin? I mean, I think we just go through this chronologically, right? Like, so let's go through it. So this stuff is just setting data. So obviously this does nothing. It just sets variables ultimately. It doesn't have any real functionality, meaning it doesn't tell the GPU to do something. From here onwards, specifically from this line, this is where we actually hit the GPU for the first time, because what a render command buffer is it's basically a class in Hazel that represents a command buffer or a command list, command buffer Vulkan, command list DirectX 12, that we can actually encode like commands to, that we can write commands into and then later execute on our GPU. So this was something that I wasn't exactly sure how I wanted to port to NVRHI, because we used to have like a Vulkan render command buffer, and it's a decently big class because it has a lot of, again, command buffers are how you tell the GPU to do anything really. So apart from like create certain resources or create, I guess create resources. So the Vulkan render command buffer class inside Hazel, basically the idea is you pass in how many, I guess, you want to create. And the reason why is because if you have multiple frames in flight, you typically want one per frame in flight. so that obviously like the scene renderer, which would create, you know, it would have like a render command buffer per frame in flight so that the CPU can start recording like the next one while the GPU might still be executing the current one. And so what it will do over here is it'll basically create a command pool. It'll allocate the specified amount of command buffers from it, right? We just set a debug name here. It also creates wait fences for them. The reason why is because sometimes I don't remember all of this off the top of my head, even though I wrote this because this was years ago. But, you know, sometimes we actually want to make sure that we pause the CPU thread while we might wait for a command buffer to finish execution on the GPU. Or alternatively, probably more likely, is if we have 3 command buffers because we have 3 frames in flight, there are scenarios in which the CPU gets very ahead and we've basically submitted this one to the GPU, it's executing, we've submitted this one, it's queued to execute, and we submitted this one to queue, and it's queued to execute, and then we want to go and use this one again, but this one's still like executing. And so we need to have a fence basically to make sure that we don't, you know, that we don't try reuse that before it's actually ready to, and in which case we do have to stall the GPU because it's getting too ahead. And then I think a decent chunk of this class is actually like this query stuff. So basically this is what allows us to figure out how long the GPU takes to actually execute a command buffer. So this is really important because this kind of timing, just lets us see like how long stuff takes on the GPU. And that's obviously really important so that we can keep an eye out on performance and identify bottlenecks and just slow parts that might want to be optimized. Now, the other way to create this, and there's 2 constructors, interestingly. One just takes in a count and a debug name. The other one takes in first a debug name, I think, which is a bit inconsistent, and then bool swap chain, which I don't think it needs to take that in because you can see owned by swap chain is actually hard coded to be true. And the reason why is because this, instead of creating a command buffer, what this actually does is it gets one from the swap chain. So you can see it only creates query pools and stuff. And as far as the actual, it looks like it doesn't create or get any command buffers because this owned by swap chain variable is then used later when we actually try and begin this command buffer so we can begin writing commands into it. If it's owned by swap chain, then it will actually get the swap chain and pull a command buffer on the current command buffer index, which is the current frame in flight, basically, or the current index of the current command buffer that it's selected. It will pull that from there. Whereas if it's not owned by swap chain, it's owned by us. So therefore we just get it from command buffers, right? We just get it from our command buffers that we actually own. Okay, and then we just begin the command buffer because we're in the begin function, obviously, and we go ahead and reset like all the timing stuff. And I think then then obviously it's up to the client or the user of this class to actually encode and write all those commands. And then obviously we call end, which ends writing the command buffer. And then to actually get the GPU to execute it, we call submit. Now, if we are owned by the swap chain, we don't need to call submit. In fact, it probably should just assert because I'm guessing you probably shouldn't. I mean, you can, I guess if you don't discern, you don't care which one it is and you want to switch between them, I guess you can leave the submit call in and it will get removed. But anyway, this just, because if it's owned by swap chain, the swap chain will actually execute the command buffer for you as part of its main submission. Now, we've re-architected this part, so it doesn't quite work like this. And in fact, the reason why we had it like this in the first place, if I recall correctly, was at a time when we supported both OpenGL and Vulkan. And because OpenGL doesn't really have this concept of command buffers, and it's just like the commands are kind of, it's almost like when you go from OpenGL to Vulkan, a common strategy, at least back then, if you didn't want to rewrite your whole engine and you want to keep the same kind of application flow going, and especially I guess if you want to support both APIs, is you kind of treated, you kind of created just one command buffer globally in Vulkan, and that's like everything you want to do, you encode into that command buffer. And of course, you know, if you want multiple frames in flight, then you could just create one per frame in flight, so that every frame you're getting the currently relevant fresh command buffer for this frame index, and then you're encoding your commands there and submitting it at the end of the frame. But the idea is you begin a new frame, you open that command buffer for writing. The duration of the frame, you write all your commands into it. At the end of the frame, you end the command buffer, and then when you do like GL swap buffers, the equivalent of that or whatever, which is your swap chain, I guess, in Vulkan, you would then submit that command buffer for that frame, right? So that's a very like one-to-one mapping between OpenGL and Vulkan. Not the best way to go, because Vulkan obviously changes the game entirely, and you don't need to abide by that. But I think that's why it existed. So this whole owned by swap chain business is not something that I think we need at all anymore. So I don't think I'll have that, because at the moment we don't actually do that. So if we have a look at Vulkan swap chain, this is our new rewritten one, and we have a look at present, for example, then we have this weird execute command lists, an empty one, and I think that's just to make sure that all these queue signals, semaphores and stuff are executed. But aside from that, you can see we don't actually do a queue submission as part of our presentation. Whereas in old Hazel, so I think I've got it open over here. Yeah, in old Hazel, so this is the net branch for comparison. If I go to Vulkan swap chain, then inside present, we have this section over here, which you can see actually calls VKQ submit. And this is the current command buffer for the current frame index, because we used to mimic OpenGL. So this is not something that we really have to do anymore. And it's actually up to, I guess, higher level external renderer systems like the scene renderer to actually maintain its own command buffer, even though that's actually what used to happen as well in Hazel. Like scene renderer, that's why this whole thing, this whole explanation of mine is actually starting from us looking at scene renderer and seeing that it does in fact create its own command buffer. So anyway, that's basically, yeah, that's the idea of this whole thing. So I'm kind of excited because it does mean that we, like for this Vulkan render command buffer is just going to really wrap the functionality we've already got inside ImGui renderer. So inside ImGui renderer in the init function, you can see we create a command list, and a command list, a command list is an NVRHI command list handle in this case. It's an NVRHI command list, which is basically the equivalent of a command buffer in Vulkan or a command list in DirectX 12. However, here's the thing. What we discovered recently is that this doesn't actually create the command buffer at all. It kind of only creates it in a way within NVRHI. It doesn't actually hit the renderer backend. And what happens is when you actually open that command list, at that point, it will either grab a command buffer that it can reuse because it's already been allocated from a pool and it's not currently in use, or it will in fact create its own pool and allocate a buffer from there. So it can do everything from very, very slow path, well, not very slow path, but like relatively slow path to reusing something and having a fast path. So, I mean, you know, if we really have issues with this, I'm not completely opposed to rewriting it, because the way that it works is pretty simple. Wow, this is just not working. Take me to here. Because you can see that what open will do is it will basically get the current queue, so it'll be the graphics queue in this case, and then it'll call get or create command buffers, or get or create command buffer, which will either grab one if the pool is not empty, it'll grab one from the pool, or it will create a new one. And creating a new one basically involves, as you can see, creating a command pool to allocate buffers from, and then allocating a command buffer from there. So and this is obviously the slower path, but if it's already got it and it's been garbage collected, it will reuse it. So long term, it's fine. It's just, you know, something you got to watch out for. All right, Deflator Mouse says, great explanation. API designers keeping swap as part of the name of the chain as a historical node. Double buffering seems to cause so much confusion for beginner graphics programs. Yeah, I mean, there's a lot of terms, you know, that you just have to know. And I think that, like, yeah, the more you work with rendering and the more you work with, you know, game engines and different graphics APIs as well, the more you obviously learn the terminology. And yeah, some of it, I guess, might be out of date, but it's still kind of relevant, most of it. So since we need, oh, and back to the scene renderer so you can see how this actually fits together and works, this command buffer is really important to this class because, and you can actually see it's really important because, so I've got it in my search, which you can't see because of the face cam. I've got it in my search. And if we scroll down over here and we just have a look, you can see that highlighted here in brown are all the places in which that appears in the search, right? It's like, there's a lot of this, and this is a lot of code because this class, this file is like 3,500 lines of code, right? So this is used extensively, as you can see. And the reason why is because for every single pass that we do as part of the scene renderer, the context for that is basically this command buffer, right? So a scene renderer, because you can have multiple instances of the scene renderer in Hazel, because you might have multiple viewports, you might have, in fact, even like generating a thumbnail for the content browser panel, it uses this scene renderer to actually render, you know, the 3D mesh, for example, that you're creating the thumbnail for, or the material. It renders it on a sphere so that you can see it in your content browser panel. That's also an instance of this scene renderer class, right? So because of the fact that it's, you know, it's kind of, we have separate instances of this, then we can't just, you know, globally add this to some kind of command buffer or whatever. That would be weird. Like, we need to create our own dedicated command buffer so that when we call any renderer command, then it encodes that command, it writes that command into this specific command buffer that we can then later execute. So what happens is inside flush draw list, so this is once we actually have a draw list of things we want to draw basically as part of this renderer, then we'll do command buffer begin. So we'll open that command buffer for writing. We'll do all of our various passes, which at the moment are just kind of individually specified in functions, but we're probably going to make this more of like a dynamic / node based system or whatever. And then, so this is actually all of the passes. There's quite a lot of them, including post-processing, and then we'll end writing the command buffer, and then we'll submit the command buffer. And we can also do an empty pass, which is important sometimes because that way it will just clear everything and make sure we have a presentable texture to actually render to. Because generally speaking in Vulkan, sometimes like if you create like a frame buffer and you've never actually written to it, then it's in an undefined state and you're not really allowed to use that. So that's one of the reasons why we might want to do something like this, but also because we might want to clear the screen from existing rendering, for example. If we destroy a scene renderer, or we move on to rendering nothing or something, right? But anyway, the point being that that's how this command buffer works. So the equivalent now, I'm guessing, is going to be basically what we did in ImGui renderer with this command list, where all we really have to do is we have to, I really need to sort out the way this class is written because init is not first. Should move that. Anyway, inside init, we create this command list, and then we obviously have open, close, and from the device, I believe, we'll have execute command list. But there's also these markers, and these markers, as far as I'm aware, are just things that basically are added to like render doc, you know, stuff like that. So if we have a look at an insight, if we have a look at what this begin marker actually does inside Vulkan queries. So yeah, so it's basically going to be like a debug marker, debug utils label, debug marker. But then I wonder if they also have, yeah, so they've got all this time stuff, which is awesome. They've got write timestamp. And this is really important because obviously we had that functionality already inside Vulkan render command buffer. All right, we had all of these like query pull results for our timestamp query pulls, and I wrote all this stuff and I'd like it to remain here. So yeah, the fact that obviously NVRHI provides a way to do that across render APIs as well is awesome. Even though I have to like definitely learn how to use this. Let's actually, so this is Vulkan queries.cpp and it's part of the command list API. So if we jump to Vulkan, but this is the header file for this, which contains the command list class, we can have a look at basically how to use this hopefully. So we have markers, but then we also have timer queries, which take in timer query, which, yeah, I don't really know how to use based off of this because how would we create a timer query? So here it is. So a timer query looks like is, so it's got begin and end query index data resolve time. And then we just have end, begin and then poll, and then get query time. So poll, yes. Oh, and there it is. This is what I was looking for. Create timer query gives us a timer query handle. Then we can begin end when we want. And then I guess either poll or get query time. Okay, so get actually calls poll. It just waits for it. Whereas poll, I'm guessing, just checks to see if it's done. But otherwise it moves on, I guess. It's just the result's not ready, it returns false. So it either gets it to us and returns true, or doesn't because it's not ready yet and returns false. So this is something that we can call if we don't want to block, because obviously get timer query will be in a while loop, just polling it nonstop until it's ready. So that will block the current thread. Okay. So, there's a lot to take in. Are you guys following along? How is this? I have no idea what this sounds like to someone who's not actually actively doing what I'm doing right now, but rather just watching someone else do it. So let's have a look at how we can, I guess, rewrite this. So the cool thing is that this is inside the Vulkan render command buffer class, right? So, all right, JR12395 mostly gets it, which is nice. So this is inside the Vulkan render command buffer, which is going to disappear because obviously since we are using NVRHI, which abstracts all of this stuff, we can actually put the stuff into just the normal render command buffer, which used to be like this virtual kind of interface. So we'll make it not a virtual interface anymore. And then if we come over here, because I still want this to compile for now, I'll just get rid of like the override. And I'll actually just make this a ref counted object so it's no longer part of that. And then that will hopefully mean that we can still compile all this stuff. I don't really need to get rid of virtual, it's more the override that I need to get rid of. But yeah, that's good. So we've stripped that out now, which means we can go into here and obviously make this now not be virtual. So let's get rid of, I don't want to get rid of all of that. All equals 0, but yeah, we'll make the API work basically the same way, I think. Like I don't really see it needing to be different. Now in terms of, so the create, I'll have to look at how we decided to do that again because I forgot how we decided to have the kind of creation API. So we just have static create at the top, which just creates the ref counted object directly. So that basically means that this stuff goes over here, and create from swap chain I think can just disappear. So we just have create, and then that will just do return ref render command buffer create, and it'll pass in count and debug name. I think like that. Yes, and then obviously we want the constructor, which typically we would put down somewhere, which also takes this stuff in. We don't need those. We'll put it into public. We'll still keep it public, but we'll put it here. This is doesn't need to be virtual. No, actually it should be virtual. It doesn't matter because it's actually virtual in the ref counter class because it's got the space class. But yeah, I just want to make sure that it's kind of there. Now, yeah, begin and submit. Now, I guess I'm gonna want to look at the stuff that's in here and get most of this stuff. So let's grab this. So we got the command list, which is the effectively command buffer. Now, yeah, note how we have a vector of these here, right? So we still want that functionality as far as I'm aware, because we obviously want to be able to have like multiple frames in flight and potentially a command buffer per frame in flight. Now, I don't really know why this is a vector, to be honest. I would not make this a vector. I would make this probably a static vector / array. NVRHI actually has a pretty nice static vector class, which I basically want to steal. And basically what a static vector is it's kind of like a stack vector. So you can set a max size of say 3, but it behaves like a vector, because if you have an array, if you just did like scd array like this, then the issue is that you, as far as you're aware, you always have 3 elements in there. And if you query like a command list and you ask it what its size is, it will say 3. But a vector, even though it has up to 3, the size currently would be 0. And you can basically kind of push back into it or whatever, as if it doesn't have all those elements. So basically it still dynamically keeps track of its size, even though it's already allocated exactly this much memory, and it's also on the stack. So you can have a look at how that works. And in fact, it actually subclasses itself from array with obviously max elements here. So it uses array under the hood, but it just gives you a vector-like API, including maintaining size, because an array doesn't maintain size. And like a standard, an std array just has return the number you used as the template, like generated in the class. So it has no size variable. It's literally just, it'll generate a function that's like return 3, and that's it. So you can't do that there. And in case it's not immediately clear, the reason why I don't want this to be 3 is like the max basically, because we have a count. But the reason why I don't want this to be just an array or whatever is because we might not have 3. We might have 1, we might have 2 if we have 2 frames in flight, and we might have 3. That's kind of like the upper limit. So we don't know if we have 1, 2, or 3 of these. So that's probably the best way to go. Yeah, then we've got like our debug name. We don't need the command pool, it does it internally. We don't need the active command buffer might be nice, I guess, because that's which one is, I don't know why. Because in begin we set this probably. So let's still keep this. Yeah, we can, I don't know if we have to set it to null pointer. I think this by default will set it to null pointer. Yeah, you can see that if we initialize it, if there's a default constructor, then it sets it to null pointer. So that's nice, means we don't have to have this code here. Why did I have it before? Because it was a VK command buffer, which is literally just a pointer / uint64t. Okay, weight fences. I guess we probably want some version of this, so I'll comment that out, but leave it here for now. Owned by swap chain, we get rid of, and then here are all of our timestamp queries. I don't know what any of this means, like why we have 0 and 2 here. Next available query is 2 apparently. Don't know why we start up with that. All I know is that pipeline statistics. Oh yeah, because we pull quite a lot of stats out of here, don't we? So this would be in here. Yeah, so you can see we actually pull quite a lot of things here. So like the number of vertices and primitives, the vertex shader and vacations, all of these stats we actually pull out of here. So that I don't know if NVRHI is going to have an equivalent for. That might need to still be done in some kind of, you know, Vulkan-specific file. But whatever, obviously this isn't vital. Neither are the timestamps, but since NVRHI does them, I do want to have them. And then we've got this timestamp query results. And we've got a vector of all these query pools, which I don't think we need to maintain query pools, but I think we just need to make sure that we can create, because we looked at this, right? Like Vulkan backend had this like create timer query function, right? And that's part of what? That's part of device. So the device just does this. And then I think the device does that, but as part of the command list, we can begin and end it. So it all makes sense to me. I think it's fine. We can obviously time how long this command list takes. And actually we'll have to put begin and end queries between certain things, I think. Because how do we do that? How do we, in scene renderer, how do we actually see how long each pass takes? So for example, the main geometry pass. Okay, so we have GPU time queries and we actually begin a timestamp query. So that's what that function is inside the render command buffer, which we have here. So this is, yeah, and then it gives you an ID. so that you can then query it. So this is all stuff that we can kind of port over. All right, Deflated Mouse is helping us here. I believe you can do things like device create query with, query type statistics. Oh, cool. So there's create query as well, not just create timer query. Create query. Okay, maybe that's not in Vulkan specifically. Let's try NVRHI.h. Create event query. So that's probably what you're talking about. And then we have, yeah, this event query, which I'm guessing event query. That might be elsewhere implemented. So let's look for Vulkan. So there's event query. Yeah, I'm wondering, yeah, like what the type is. I mean, there's commandless ID, but yeah, it's just event query. How do we specify which event or like which? Anyway, I think we'll cross that bridge later. But it is interesting. Poll event query, wait event query, set event query, reset event query. It's not. So that's implemented in Vulkan queries. Yeah, so it's all in Vulkan queries, it looks like. But yeah, I have no idea, like event query. What kind of event? No idea. Anyway, whatever. We'll cross that bridge later. So, so commandless get handle. I guess this can get. It depends because we have so many of these that well, we might have so many of these. So I guess get handle will take in an index of 0 by default because that way we can have this function normally if we just have a single one. And we would just return index and obviously hope that I'll just do a core verify to make sure that index is less than command list.size. No suitable user conversion. Command list handle add. I can't see the error message because of that thing. I think it's just not compiling because it still thinks I'm returning the vector and not the actual element inside the vector. Okay. Yeah, because in the CPP file at the moment we've got like nothing. So none of this needs to exist, and then we're gonna have to start implementing like all of this stuff. Okay, and then obviously I also want the constructor and stuff, which it did not create for some reason. And I don't know if the destructor needs to be implemented because now that it's a reference counted object, like as in the NVRHI command list is, they're all reference counted objects. Okay, so so let's basically the short of it is we need to make sure that we go through count, I guess. So the first thing is if count is 0, because you can, like if you noticed, 0 is actually the default, which sounds counterintuitive, but basically all this means, according to the existing implementation, is that we just take the command buffer count from the number of frames in flight, right? So I'll actually copy this exact code with the comment and everything because it's helpful. And we'll grab this I don't know if we need that. Count is command buffer count. I guess we'll just do count, and we'll change count to be frames in flight. And then we need to go through and allocate enough command buffers for that. So because we don't actually we do the allocation as kind of like a lazy loading thing technically when we open the command list for writing. So all we have to do here is basically go through the count and probably just do command. So let me call this command lists for one. Command lists I equals, and then we just need to create it. So if we have a look at ImGui renderer, let me just have a look at. So yeah, so we need the device, and then we can do this. So this is good. We can actually test this out by moving ImGui renderer to use this instead. And then, yeah, that'll make sure that we test it out, I guess, before we... It's going to be harder to test in the scene renderer where nothing else works. Okay, so then I mean, you know, begin is basically as simple as... Well, actually, we need to make sure we get the logic right. So begin... does it on the render thread, interestingly. Yeah, this is where things get a bit tricky. Because this all happens on the render thread. That's why we have renderer submit. Whereas, like, well, for one, we're already on the render thread inside ImGui renderer, I think. And inside, are we really? And inside ImGui layer, we'd have to be probably. Because I think this does ImGui layer end on the actual render thread. So yeah, an app render ImGui. Oh, really? Oh, so going through the ImGui layers, we're actually going through the CPU side ImGui rendering is actually on the render thread as well. So yeah, so we need to make sure that if that's the case, that we actually have probably an RT begin, otherwise we'll, which means we're already on the run thread, otherwise it will submit it for the next frame and we won't get anything done. So that's an important thing. So let's copy like all of this. Obviously I'll cut out most of it. And then I'm actually going to make render thread versions of these. So the prefix of RT in Hazel, if you ever see this, it means that basically this is intended to be called from the render thread. So what typically will happen is if you see that a class has versions of these functions with RT, that means that this will actually immediately do the work, and the ones that don't have RT will actually submit the work to be done on the render thread. So effectively this function calls this, but it doesn't call it directly. It submits it to the render thread for execution, I guess the next frame technically. So the reason why this is nice is because it means that if the calling code is on the render thread, then we can directly call this function. Otherwise it wouldn't make sense. And we don't have any logic. We don't really want to have any logic inside the render thread submission code that, like, you know, detects what thread you're in and then does the appropriate thing, because sometimes that's also a bit undesirable, and also that's extra instructions. So yeah, that's the story of these functions. So basically this is going to be really straightforward from this side, because begin will simply call renderer submit, and then it will basically, you'll have to get the current instance, but it will basically call RT begin, right? So we'll do something like instance RT begin, and then we need to create an instance of this to submit. So we don't really need to do this here, I think. Can we do an instance equals ref? I guess we don't want to do this because this is a pointer. So we probably should do, but that makes it kind of long. This, right? So that's basically the code, but because this ends up being kind of long, I think what I end up doing is cutting this out, putting it here, and basically rearranging it. So this is also why we need intrusive reference counting, because we can do stuff like this, whereas you can't do that if your reference count is not part of your object. Okay, so that's good. And then this is basically what we do for each of these functions, begin, end, and submit. RT end and RT submit. And then the RT functions, the render thread functions, they do the actual work. So I'll copy them. Probably should have got Visual Assist to generate for me, but oh well. All right, cool. So, yeah, I know, RT ray tracing. RT predates the introduction of real-time ray tracing, for sure. Okay, so RT begin. So yeah, so now we just implement, I basically copied it, but I'll copy it again. So this is what we do in begin. Obviously we don't do the submission now. Yeah, so this kind of timestamp query behavior, I will just leave it here somewhat, just because I want to make sure I know what I used to be doing. And then obviously we don't need any of this, but we do need the logic of our current frame index and stuff like that. I hope this, so this actually gets it from the swap chain by querying the current back buffer index. So that should work, but I'll make sure that it does. Owned by swap chain doesn't exist anymore, so I guess this needs to, yeah, this definitely needs to fly. As in we definitely need to make sure this works. And then command buffer we get from here. And then that's the one that we begin, and we also set active. So let's just set active command buffer to, so command buffers so this is actually command lists. And then active command buffer is command lists at that index once we make sure that it's not exceeding, that it's sort of like wrapping around. And then begin command buffer is we just do active command buffer open, right? And then I guess we'll begin, we should begin, because there was begin timer query as well, right? And we would have created the timer queries already, I think. So this maps to command reset query pool and command write time stamp. So this, you can see we used to do reset query pool and write timestamp. So this is exactly what we want to do, which is great. So, but to do that, we're gonna have to create that stuff first. So we'll create the command list here in the for loop, and then we'll also create timestamp queries. And this will just be device create timestamp or create timer. I guess I'll call it timer query. And then that returns a timer query handle. And we need to make sure that we have our static vector of command lists, and we also have a static vector of timer queries. Up to 3, I guess, 1 per frame in flight. So we'll pass in, maybe we should have active timer query. I don't know, I might get rid of this, we'll see. I'll just entertain this idea for once, like as in, I'll entertain this idea. And then if it doesn't work out, it doesn't work out. So this will be timer queries at command buffer index. And then we begin the active timer query. Yeah, and that's it. That's kind of it. So that actually does this. So we're still missing the pipeline stats query, but we'll explore that later, I think. Because I don't know if that works. If NVRHI has that, I haven't found that yet. So that's RT begin. Let's look at end. So this is basically what end does. Owned by swap chain is not a thing. So we do have to do this code. Why do we do this here though? Oh, because we just need to basically retrieve this because we don't store the index for some reason. I don't know if that's a good idea, but whatever. And we basically get it, and then I guess I can put group these two together. Then we get the current active command buffer. We have to do write timestamp and end query, which I think is what end timestamp does, or end timer query. So maps to command write timestamp as well, and hopefully does end query. And then this will be our active timer query. Yeah, so what's the point of this even? For end query, I guess. Because otherwise it just sets, so yeah, it sets this to nothing. So that's pretty straightforward actually. I don't think we need, we don't seem to need this. We just do end timer query, and then we're gonna close this. And I think that's it. So really simple. And then submit is obviously the juiciest part. Owned by swap chain is not a thing anymore. So then we kind of go through here. We do a device lock queue, which basically just has a mutex because you have to synchronize submission to GPU queues. And also query pull results, I guess, to retrieve timestamp query results. Yeah, sure. Whatever. Let's do this for now. And we probably want markers as well. We definitely want a marker API here. So let me actually, because I definitely don't want to forget that. What is going on? Okay. My caps lock got stuck. Markers. Because then you can just add like a marker every now and then, and also maybe refine the timer API so that you don't have to keep doing this. And I guess I'll change this to timer query instead of timestamp query. And also none of this stuff has to be virtual, and this is also currently not really available. So begin timer query and end timer query. So that kind of happens automatically when we do begin and end, but I guess you want to insert timers within. That's why it gets a bit complicated and you have like query IDs, because this kind of begins a new one, I guess. So basically, because there's two different timers going on here. Like as in, there's the ability to time how long this entire command buffer takes, but also you might want to query sections within this one command buffer, because you might encode all of your render passes into a single command list, but obviously you might want to know how long each one takes, and that's why this is important. But yeah, I think ultimately this will probably have to return like a timer query handle, and then obviously when we do end, we take this in. And then when we have get execution time or whatever, then we have query index, which I guess was called query ID. I don't know. We're going to implement that. We'll see. Let's do submit first, though. We're getting a little bit ahead of ourselves. So submit. So we won't worry about any of this stuff. We'll basically just make sure that and then the fences as well. I won't worry about that for now. I think we'll just get this up and running, and then I'll see what I need to do. But I think we will probably need the fences, because they make sure that we're not getting too ahead. And in fact, if we look at what the fences do specifically, you can see that they basically, yeah, so we get the current command buffer index, and then that has a fence associated with it, which we have to wait for it to complete before we go again. So before we submit like the command buffer, but this, I don't know if this makes sense, because wouldn't we have already encoded it with new things? And also this takes in the wait fences. Or like it takes in a fence. Well, I guess that makes sense actually. Yeah. So we submit it with this fence, and then when we roll around like 3 frames later, we land and wait fences for that specific fence. And so if it's still not done, that's when we wait for it. So yeah, so we'll see if we need to add that. I'll just do a little to do here. Okay, cool beans. So what do we do now? I guess we can add this. Oh, whoops. We're in the wrong function. RT submit. Yeah, and then we basically just do device execute command list. And then the one that we want is, yeah, basically, because the thing is we don't really have the active command buffer anymore. So one of the things that this was supposed to do is it was basically inside end, was since we end the timer query and everything, it was supposed to kind of set this stuff to null pointer. I don't know if we still want to do that, but basically that just means that we don't have any that are currently active because we've closed them here and we've done, we've ended the timer query as well. And then, so that means that if we actually want to know which one we are supposed to be submitting, then it's the, I don't know if this is necessary though. There's no real reason. I mean, it makes sense because this just makes sure that, because it means that if you do get handle, at the moment it actually returns 0, but you probably should have something that's like get active. Yeah, I don't know, I guess get active or something that just returns the active one. And so that can be null. And then maybe just get. So get and get active. Or something like that, I don't know. Get active is probably what you should prefer. And then the reason why I kind of like that design, I guess, is because it means that basically it just means that you getting sleepy. It means that you can basically, if you try and retrieve it and it's null, then you're kind of like, okay, well, I forgot to call begin, or I already called end and I can't encode more. Whereas if I make this never go to null pointer, then it kind of makes it look like you can keep writing commands, whereas you can't. Because even though it will technically work, you haven't opened it, so it's not, you shouldn't be doing it basically. So I guess I like this. So that just means that we need to know which one we're trying to submit though, which basically means we need this. And then we use that to get, you know, command lists at index command buffer index. And then this is important as well because even though we might have 3 frames in flight, for example, we still might have only created 1 command buffer, so that's why we need this every time. I don't know why, like we could obviously write that on 1 line, but whatever. That way we can debug it better, I guess. And then yeah, we just execute the command list. Okay, cool. So, and then yeah, as far as queries go, so I think, how did we used to deal with that? So we had begin timestamp query, which I see that just wrote a, and then it just did this. So it didn't actually create a whole new query. Okay, whatever. We'll come back to begin this query stuff when we actually get the rest of this working, because we can't test it. I have no idea how it works, and we can't test it at the moment.
Yeah.
Okay, so basically we've implemented everything here, I think, and it should work the same except for weight fences and queries. So not too bad. The constructor. Oh, we had the constructor generated down here. That's funny. And then obviously, yeah, the get pipeline statistics, like, do we still have them somewhere? Yeah, it's a vector. Let's make it a static vector of 3, max 3, and we'll have this return 0. That will probably be a set though, unless we specifically. Oh, yeah, I think we have to do like pushback or something here because it's like a vector, so we don't actually have the memory already allocated. Is there an in place back? Yeah, there is. Can I just do that? Yes. Okay. We can just do that here to put in an empty, a default constructed one. Cool. Every time a query has an implicit fence, you can either wait on. Okay, sure. All right. Are we okay? I think we're okay. Just fill in all of these empty returns. Let's try to compile this file. So we get. We've already got a body for the destructor. I'll get rid of. Did we have one here? Oh, it's equals default. Okay, yeah, we'll get rid of that. Because everything is will be automatically cleaned up. Okay, so that's done now. So if we go back to the scene renderer, so yeah, begin. I'll have to rename begin timestamp query to begin timer query, and then same with end, obviously. Oh, but also all of these queries, ugh, I don't know if they'll end up being like this, but they all have to be timer query handles, I guess. Is it worth me doing this? Okay, and then end. All right, let's see if that compiles. Okay. But yeah, the point is this command buffer now, we create 0 of it, which means that it will, I think I might, since we're changing this API, I might just change it to, but I guess the debug name might not be required. I don't know how I should organize this because 0 looks so weird here. The advantage of using create as well as you can add words to it. So you can be like create, you know, auto or whatever, or create with frames in flight, or, you know, create specific amount, or you can add stuff to it, which is nice. But I don't know, because I don't really want to put the debug name first, because that's obviously, but then again, like, I don't know, we've stopped caring about stripping things like debug names for real, like, distribution builds, like, as in, because like, I feel like back in the day when computers and devices, any devices were slower, what was like kind of important is that if you had strings, even like debug names, you'd basically make sure they were stripped for distribution builds. So you'd have like a if and def, you know, dist, then have this, otherwise you won't. And that way, like, you'd save a little bit on performance and memory, because obviously, like, you know, this debug name would kind of be like you know, if ndef hz dist, right? So you only have this if distribution is not defined, and then that way if you switch to like distribution, then that is gone, basically, as you can see. So, but I feel like that doesn't matter as much these days, just because it's like, it's just a little string, and like, it's computers are fast, but I don't know if that's a good mentality, because usually I'm against that mentality, because that's how software ends up being so slow, as it usually is these days. But it's just a string, on the other hand. So I don't know. What do you guys think? I think this is going too hard, to be completely honest. So I'm going to leave it like that for now. So therefore, like, I feel like you'd always have a debug name, because why not? And then in terms of like hackability and security and stuff, I don't think that's a big deal either. Like, people can hack the rendering if they want. I mean, obviously that could give you an unfair competitive advantage if you like hack the rendering to the point where things are transparent or not there, and you can see through walls, but that's only for like a multiplayer game, and I don't know. What do you guys think? Does any of this stuff really matter? Or are we just doing, well, there's nothing that we're doing matter, you know? Okay, I'll leave this as is because I can't be bothered. So what we'll do then is we'll go to ImGui renderer, and I want to flip this over. So we have a command list handle here, whereas what I'm going to do is I'm going to include Hazel slash renderer slash the thing we just did, render command buffer, and then we'll have render command buffer, and then obviously we'll have to do render command buffer create. So we'll do, so here we weren't doing 1 per frame in flight, but we can do it here if we want. We could do 0, which would be 1, because if we wanted 1, we could say 1, right? And then we would do debug name, which would be ImGui renderer. At the very least, this means that we can actually add implicit markers already if we wanted to, which is kind of nice. I think we were doing that here. But either way, so we do render command buffer begin, and then you can see it does a begin marker. So let's actually make it do that marker automatically. I mean, we had a special marker here because we wanted to know what the main viewport was, but we don't really need that. So if we copy this and we go to, we can still have begin marker and whatever else if we want, but I think that as a minimum, it should begin a marker with the debug name. So we'll do open, and then we'll do active command buffer begin marker, and then this will be debug name.cstring, and then I'm guessing we also have an end marker. So this will be get active. By the way, one thing we could do to make this slightly easier, which I'll have a look at in a minute, is have an implicit cast to an NVRHI command buffer handle. So that would just make things like this kind of easier. Because at the moment we have to basically do get active and then do that on that. Whereas we could have this be an implicit cast, and at least that way it would actually work with, like, we could just pass it in like this, for example. I mean, obviously update geometry is our function, so we could probably make it, you know, we'd make it take in this, but also, I don't know if we'd need to, because this is just getting called from here now. So it can just do it inside update geometry itself. So we'll fix that up. Where was that end marker? So end marker is just end marker. Okay, so it doesn't specify which marker to end. So you can only really have one marker at a time, which is a little bit annoying. I thought you could have more than that. Multiple layers of markers. But I guess not. Okay, I think end marker goes first, because it's the last thing to happen here. Do the queries and markers grouped. Yeah, so the way that would look like, and I don't know, it might be a bit confusing because it only gives you the active one. Yeah, that would be confusing, wouldn't it? That's the problem. I guess you can't. I guess we can't do that. That would be too confusing. So because what we could do is we could basically be like, you know, operator command list handle, you know, and that would return active command buffer like that. And so what that means is that inside our ImGui renderer, it would basically mean that we, if we have a function like clear color attachment that takes in a command list like this, I mean, it's not really a handle, so it probably wouldn't work. But otherwise, because see, this one's specifically that, so there's actually two conversions, even though they're the same. So you'd have to probably add another one that was like I command list pointer, because that's the same as a command list handle. And then that would just work. and then that means that you can, you should be able to pass that in, which is not really working. Oh, maybe because it's a ref. So you'd have to like dereference it and then it would work. But like, I feel like it's less ambiguous if you do get active, because it's definitely the one that's active, and you're also, that can return null. Whereas before you might get null without even assuming it or something. And then also you have two different, functions here. Get with a specific index, which will never give you null as long as it exists, and get active, which will give you null if it's not there. And that might be important because you might want to just get the handle for later use, and you don't care that it hasn't been started for writing, it hasn't begun. Okay, so for stuff like this, yeah, what I would probably do if we have a lot of this stuff is you could just do like NVRHI command list handle command list equals m render command buffer get active. And then obviously you can just use command list as normal. So I might want to do that here. So we'll do begin, and then we'll immediately get that active one. And then that way we can do all of our writing just like this. And then we can execute it, but we would execute, yeah, close and execute. We wouldn't do this way. We would just do render command buffer end, because it does all of the query stuff as well, and also submit. Actually, yeah, that's right. So in this case, we have to use the RT functions everywhere. I totally forgot about that because we're on the render thread. And the create one has no render thread. Now this actually will, this kind of needs its own one. I mean, not necessarily, it just wants to execute it immediately. I guess that's fine. You can just use the current one, sure, why not? So let's do begin. End. And submit. Oh, sorry, on the render thread. And then we'll grab our function, our little variable thing. Okay. Cool. So yeah, this is exciting because we can check to see if this works or not. So we have to go into, let's see, editor, where's my editor layer? Because we have to go back to not having a viewport renderer, which I already deleted, which is annoying. Let's get that back with fork. So we used to do that. I think I just commented it out. But I did get rid of, this is just comments that I got rid of. So I didn't actually get rid of anything, it looks like. As long as we create the viewport renderer, like so, we should be fine. Yeah. Okay, cool. So let's run this, and yeah, we're gonna see whether or not it works at all. If we get our UI and everything and the editor works, then we've successfully done it. Otherwise, we have failed. So let's see. In the meantime, if you guys have questions, then let me know. Oh, we got some errors. So this probably wants to do get active, I'm imagining. Yeah, instead of get handle. Oh, and then what's the problem? So create from swap chain, we used to do swap chain target. So this needs some investigation. I'll just make sure we don't hit this, because this shouldn't really, well, we'll see, but I mean, all it does is create a random command buffer from swap chain anyway, so we probably won't do that. This I think we're already fixed. Yeah, let's compile again. Okay. Oh yeah. So this is all yeah, so what do we change this to? Query, this still takes in a query index. Let's just make this take in a handle. For now. So that it compiles. Right, and if you pass in nothing, it's supposed to somehow work. I don't know how that's... whatever. It's supposed to just give you the overall GPU time for that scene renderer frame. Whatever, it's gonna need an overhaul, I guess. Hey Lorenzo, thank you for the Prime sub. Appreciate the support. Should make the little Cherno logo there like a Hazel logo. Spinning Hazel logo. Because we've been working on Hazel a lot lately. Hey Atomic Blom, thank you for the Prime sub as well. Appreciate the support. We got a little hype train going. Forgot about Prime subs. Yeah, everyone with Prime subs who wants to support Hazel and me, then please subscribe. If we can get enough subs, I'll do something. I don't know what you guys want me to do though. Someone pronounced your nick correctly. Purely Virtual, thank you for the Prime sub. Thank you. How would you pronounce Atomic Blom incorrectly? Atomic Bloom is what I first read. Choo choo. Oh yeah, it works. I just realized. I forgot what we were testing. Awesome. Well, yeah, I mean, I'd expect it to work, to be honest. That's the other Hazel, probably. Yeah, we're pretty good. Cool. Awesome. So, we can even hit play. But hitting stop is not good. Anyway. Yeah, cool. So we got the... Hey, Deflated Mouse, thank you for the sub. And Mori too, thank you for the sub. Thank you, guys. Look at that. It only takes one. Lorenzo. This is all thanks to you, Lorenzo. Thank you guys for the support. Appreciate it. What should I do? Should I do something special? Because you guys, how many subs is that? 1, 2, 3, 4, 5, 5? Yes, 5 subs. I don't know what to do though. I don't really have any sub goals. Guess my sub goal is just to keep working on Hazel, which is nice. I don't know why this is an error, because it's not, but whatever. So, yeah, so the next step after command buffer, after creating like this render command buffer, is all of these uniform buffer sets. Now they're pretty simple, to be completely honest. Do you have a funny hat? You know what? I could probably dig something up. I think I could. I'll be right back. So this isn't exactly a funny hat, but I can wear this. It's a little Australia hat, see? So, there you go. Now I look like a farmer. All right, let's round up the cattle. Okay, and people are gonna be so confused, but that's why I got my, yeah, and the thing is, if I angle it up, you can't really tell, but this is gonna be a bit unfortunate. Okay, so I got like 4 of these. I mean, like, I think me and my wife have like 2 each, because some of them kind of broke. It's just nice if it's sunny outside, you know, doing some yard work. Or going to the beach like on Australia Day. Damok, thank you for the sub. We're gonna switch this up into like, I don't know, what's next after the hat? Okay, so uniform buffer sets. So I think these are sets of uniform buffers, and I don't know if uniform buffers, I don't think we've ported uniform buffers yet, but they're pretty simple. Like, they're really simple. Like, this is all they are in terms of Vulkan, you know? We just needed the ability to obviously set them from both the render thread and the main thread. Do I use ImGui for the engine runtime or just the editor? Just the editor, so just like the tools. So we have our own kind of UI for text rendering and sprite rendering, 2D rendering basically. But we don't have like a full-on layout system for UI. So if you wanna make some kind of UI like a main menu, you actually kind of have to program that in C# more or less yourself. So do like all the math for the layout and stuff. We have some stuff, like as in, for example, if you want to get, you can have text inside the 3D scene in world space, or you can have it in screen space. Like that's included, I guess, on the text component. You can actually just pick whether or not you want screen space or not. And it does use our text rendering, and Hazel itself uses like SD, it's like signed distance field rendering. So there's no such thing as like a font size. You just set your scale, and if you're in a 3D world and you're like a first person camera, you go as close as possible to it's always like really sharp and nice. The edited UI is ImGui, but it looks so good. Yeah, I don't know. Some people think ImGui, I don't understand. Like it's like ImGui, it's always been weird to me when people think that it's ImGui, so it can't look good. Like it's like the opposite. It can look good, because it's ImGui. Because ImGui is just using your like, you know, GPU and your graphics API to render it itself. So you could do anything in there. It's literally like a 3D viewport, you know? So anything you can do in a video game, you could do in ImGui. So it's actually extremely flexible. But yeah, it's nice to obviously, like, most of the UI work actually was done by this guy called Jay. I'll give him some credit because he's great. So if we just go to like hazelengine.com, this is the roadmap, but on the Milano board, if you go to team, then yeah, Jay here from Ukraine. So he is primarily like the audio guy, and he's just a volunteer here. He's primarily an audio guy, but he also did all of the tool UI because he, I don't know, he just really likes UI. I think he just really likes making things look nice. And so he, yeah, he did a lot of work on that. So the reason ultimately that Hazel looks so nice is mostly because of him. I mean, everyone on the team has like contributed to the panels and stuff, but he kind of set up that style that you see. And obviously it's kind of based and inspired by Unreal Engine, but yeah. Oh, I've earned a hype chest. Open to see your reward. This is kind of exciting. Open. That's a serve emote, and I can hit share. Okay. I don't really know how Twitch works, guys. I mean, thank you for the subs, but I'm a very bad Twitch streamer. I feel like I'm too old for this, even though I started... No, my first time that I streamed on Twitch, I was probably like 20 or something. Maybe younger. The first time I ever did a live stream, I'm pretty sure I was like 16. And now I'm 30, so... You could say I've been streaming for 14 years, you know? I've been programming for 14 years as well. I stream and I'm 55. There you go, man. That's the dream. That's like, I'm probably going to be doing that as well, to be completely honest. All right. Anyway, yeah, let's knock out these uniform buffers because they should be super simple. So we'll do the same thing that we did before, where we'll just go to Vulkan uniform buffer and unplug it. Ref count, that's embarrassing, that template argument I added there, no one saw that. So let's do that here as well. We'll just make this be a standalone class so that we can keep it for reference, but it won't rely anymore on the base class, which we're going to change. So we need to grab this, put it up here. We'll keep the set data functions, but obviously they won't be pure virtual anymore. And we'll create this with a particular size. We'll have our constructor. I don't know if the size should be a uint32. Like, probably should be a 64. Generally, sizes are 64. Now it's probably a good time to refactor that. Just because, like, to be consistent with like our buffer class, our CPU side buffer class, which has sizes of 64, and then obviously size T is a 64-bit integer. So since I'm rewriting it, I might as well just make sure that it does that. We'll add in that virtual destructor, which I can just do equals default. And in terms of private stuff, let's have a look at vertex buffer, because that has a NVRHI buffer handle, which we'll take, as well as a size. Local data, probably don't need, at least not yet. Now, I kind of want this to be a buffer instead of individual data and size, probably. That's going to be a big change, though. Maybe we'll support both, because it might be a little bit better. Like, as in, it might be a bit more, like, convenient from an API point of view. Okay, so let's create all of this stuff. We can kind of loosely refer to the previously existing class, but so like Vulkan uniform buffer. Oh, so there was local storage. Oh, well, yeah, there kind of had to be, because we have to copy it from... okay. Yeah, so I guess we'll take that as well. We'll have our local storage. I don't know why it's a uint8t. It should be a buffer. Kind of like it was in vertex buffer. So when we do this then, so what's your problem? This is wrong. Oh, this is all wrong. Oh, no, that's vertex. I thought this was the constructor. So that needs to be here. And then we don't actually need this because create will just return the ref uniform buffer create with size. So we'll do local data equals buffer allocate size. Now it's like dot allocate, I think. Is that how we did it in vertex data? In vertex buffer rather. Oh, actually in Vulkan uniform, but oh, we didn't do it that way. Yeah, and then we didn't really do this here. We didn't submit it. I would argue having data plus size instead of buffer as a parameter is more convenient, so the user knows first part of the buffer object if they already have data size. Well, you don't really, yeah, like it's a little bit more convenient, but you can just wrap it. So like, I think we did that for vertex buffer, so I might actually do it here to be consistent, or I'll provide both. And basically the way that looks is that you just write, if you don't already have a buffer, so this actually looks like it does. Really? Frame index. Maybe not. Oh yeah, well this doesn't. How does it? Oh, that's wrong. Because this, it thinks the data size is the offset, so that's not gonna work. Huh. But anyway, if we look at one example of maybe where it does work. Yeah, and see, this is all going to be broken unless I change it. Yeah, I don't know. I think ultimately I probably support both. And storage buffers we need to also do. All these different buffers. Yeah, I think what we should do then is we should have, yeah, we'll just have multiple versions of this. So we can have const void data and uint64 size. Now we can't have offset as a, or can we? Because this is somewhat ambiguous, isn't it, with the default arguments? I don't think that will work. And the reason why is because since buffer can take in a void pointer, but it really shouldn't, because this is probably bad. Why would this be able to implicitly have a size of 0 if you pass it a pointer? That doesn't, I want to get rid of this. This doesn't make sense. And we might want to make this explicit, because otherwise it will probably destroy things. Because this actually having a default argument of 0 is the reason why everything was bad. Now it should be better. And what I'll probably do with this is I'll just call set data, but buffer data size and offset. Doesn't matter, either way is fine. RT set data. Oh, I thought about adding a WebAssembly target to Hazel. Not really. Like, our priority is kind of more or less high definition, I guess, PC kind of games and console maybe. So it's like the HD titles rather than, like, I just don't imagine any. I know that obviously web is very capable these days because it just uses normal GPU and everything. But I don't know. The games that I imagine shipping would probably not be on the web. But that being said, if we had the resources to, which, you know, we might, if someone wants to volunteer and like help at it or something, then like I wouldn't be opposed to it, just because I feel like obviously that would be amazing for like game jams, and going forward web is becoming more powerful in the sense that we can actually get pretty much native performance from it. So I don't know, like, yeah. Maybe. It just personally as a platform doesn't interest me that much, so therefore I'm less inclined to want to dedicate my resources to it, if that makes sense. But that being said, yeah, there might be scope for it in the future. Okay, so now that I've done this, hopefully that fixes some stuff up. But again, I don't know if this will work because, oh, it should now that I changed buffer, right? So this now should compile as not this, hopefully, but as this. I think it just doesn't know which one it's using. But let's just try this. Cannot convert from null pointer to Hazel buffer. Oh. Well, buffer by default is null pointer. So the equivalent here would just be this. Let's try compile everything. Okay, this I guess I haven't finished yet. Okay, let's go back to vertex buffer. We'll grab NVRHI. We'll keep going. So, allocate. Oops. Keep pressing Control S, but it's currently writing stuff. So we'll have two of these functions. One that takes in a buffer and one that does not. Let me just get that order as well. The simpler one, I guess the shorter one up top. And then set data. I guess basically, I mean, we have to create it as well, but this will, I'm just gonna get most of this from, I have to make sure we free that local data. I have to get most of this from, oh, why am I in here? Most of this from the vertex buffer class, because it's basically the same thing. It's just the usage is gonna be, okay, so a uniform buffer. Unordered access is probably a storage buffer, right? You know what? We can see. Oh, that's the initial state anyway. What's the usage? Like, how do we set the usage? Or is that basically... And the debug name. We should probably have a debug name. And CPU access we'd need to set. So none is default, which is probably wrong. Oh, constant buffer. Constant buffer would be a uniform buffer. So if we have a look at, we can easily check if we go to like Vulkan buffer probably. Actually, I don't know where they, where this stuff is. Yeah, so is constant buffer gets you uniform buffer as the buffer usage. So that means you need description. You need to add that to the description. So that needs to be true. And vertex buffer is obviously false, not set. And initial state, we can, I guess we can set it to constant buffer. I don't know if that should be the initial state, but whatever. But yeah, we keep that as well. Oh, okay, that's right. So this is what we did, what we discovered later to do with textures. And then yeah, debug name. I think we should probably do debug names, but we'll worry about that later. Okay, so this is our, let's call this buffer description. Where's my lowercase b? Okay. So set data will do this. We'll get it to submit it to the render thread though. Right. Oh, maybe not. No, well, yeah. Yeah, so really this is the only code that will actually do that stuff. So I guess we can call this buffer so it's not ambiguous. That'll make more sense. And yeah, that's like it. And yeah, we could use random command buffers, but we don't need them in this case, so we'll just do this, I guess. And then that will reuse one from a pool. It seems pretty good, to be honest. I might keep that for now. So ref uniform buffer instance equals this. Instance, and then we'll do instance rt set data. So yeah, so this is where the local data comes in, because we're not doing it here because we're doing it straight away, which is a bit wrong, but we should be basically doing this. Actually, I think this is what we can just do, right? Because that will just do the mem copy and but it allocates. Oh, because it's static. We've already done the allocation, so we probably don't want to. Is there a local copy, or I mean, there's a write. I guess we could do write. And then there really should be a version of this that takes in a buffer. Ah, that's the destination. Oh. That's a blunder. Why is this an error type? I didn't include buffer. Okay, cool. Yeah, so that kind of is okay, I think. Obviously this will copy data into an allocated buffer because it defers it and we need it to stay relevant. So it's probably better to use this if you can. Okay, what's your problem? Data and offset should be fine. Let's compile that and see if it works. No. Mutable. Because it's not a const function. Okay. Alright, so that's uniform buffers done, hopefully. Seems like there should be. And a uniform buffer set is just a set of uniform buffers. Oh, but really, we have a Vulkan uniform buffer set. Why? Isn't this like totally generic and not Vulkan specific? That's really weird. Okay, yeah, that is weird. We can somewhat get rid of it mostly. Like as in, it's literally, it's very weird that we have that. Let me keep that create though. Uniform buffer set is just a set of uniform buffers. Yeah, I meant more that it's just like, it's just got normal uniform buffers inside it. It doesn't have any API specific code. And the reason why we have uniform buffer set, by the way, is because this is kind of like, we just have one per frame in flight. Because if you have like a uniform buffer that has your camera data, because your CPU could be a frame ahead of the GPU, if you have multiple frames in flight, then obviously the GPU might be reading an existing uniform buffer with camera data to render the current frame, while you want to already be writing the next frame's camera data into a uniform buffer. So you need more than one. And uniform buffer set is just an abstraction over that in Hazel, just to make it a little bit easier to deal with, so you don't have to worry about like, okay, give me the right uniform buffer. It just handles that all behind the scenes, and you can just pass in a uniform buffer set basically anywhere where you could pass in just a single uniform buffer, and it will appropriately select the right one. So it's pretty nice in that sense. Okay, this is unfortunately all implemented in the header file as well, which is super weird. But anyway. Yeah, so we can get rid of this create. We'll just return. That's probably okay. I just want to move most of this to the CPP file. Why is this being weird? Maybe because I already have implementations. Oh, that's why. Cool. Yeah, that goes away. All right, cool. So that means that a Vulkan uniform buffer set, don't know why that even existed, that can be deleted. And that means in scene renderer, that should basically now work. So we create all these uniform buffer sets and stuff up here somewhere. There it is. So that's all good now, I think. And then we create storage buffer set. So a storage buffer, yeah, is also kind of follows the same pattern. So we'll probably take a look at this next time. It creates a Vulkan storage buffer set, which again is just generic. I don't know why it's a specific Vulkan version of it, but it does have storage buffers, and those can be great. Why is it a remote operation? Why can you not just let me program locally? This is a good time to probably end the stream on this garbage. All right. Oh, there we go. We're apparently typing a character. Oh, no, it's still gone. All right. Thank you guys for watching. Hope you enjoyed the stream. Patreon.com/Cherno if you want to help support the project and get access to everything I've been working on, as well as actual working versions of Hazel. Next time I'll be streaming probably Wednesday evening my time. There is a schedule up on Twitch, which you can take a look at to see what time that's going to be and what day it's going to be in your local time. Also on Discord, there is a channel on my Discord. So you can go to discord.gg/thecherno, I think, to join my Discord. There is a channel called Cherno Live, and that's where I post updates, like if I'm going to be late to a stream or if I'm rescheduling a stream. Like, that's a good channel to kind of pay attention to, as well as you can also write messages in that channel. So if you want to discuss live streams or suggest stuff, then the Cherno Live channel on Discord is the best place to do that. Thank you for watching. Thank you for all the support today. We got like 7 subs or something. So appreciate all of that. And yeah, have a great day. Have a great night, whatever it is. Have a great life. I'll see you guys next time. Thank you for watching. Goodbye.